So let's talk about one of the biggest challenges in AI today. You've got access to these incredibly powerful, massive language models, but how do you actually teach them to do the specific thing that you need them to do?
And that's really the big question, right? You want to specialize a model. You want to make it an expert in your world, whether that's finance, medicine, or even just your company's internal code. But these models are absolutely gigantic. So how in the world do you go about retraining them?
You know, for the longest time, the only real way to do this was something called full fine-tuning. It means you take the entire model, every single one of its billions of parameters, and you retrain it all on your new data. And hey, it's powerful, it definitely works, but it comes with some pretty serious drawbacks.
Yeah, full fine-tuning is an absolute beast. We're talking about massive costs for GPUs, a super complex setup, and training that can take days, sometimes even weeks. What we actually need is, well, the exact opposite of that. We need something that's efficient, simple, and fast.
So for most folks, this gap created a huge problem. Basically, a giant wall. The best method was just completely out of reach for almost everyone, locked behind this huge barrier of cost and complexity. But then, something came along that just completely shattered that wall. A new technique called Low-Rank Adaptation, or LoRA for short, burst onto the scene and, honestly, it changed everything. And the pace of innovation here has just been wild. In 2021, Microsoft Research drops the first paper. Just 2 years later, in 2023, a new version called LoRA makes it so accessible you can run it on a single gaming GPU. And now, we have studies confirming that this super efficient method can actually perform just as well as that old, heavy, expensive approach. The speed is just incredible. Think about this. The very first LoRA paper showed you could get basically the same results while training, get this, 10,000 times fewer parameters. Instead of changing the whole model, you just slot in these tiny trainable adapters. It was a massive, seismic shift.
And it's not just about training fewer things. A big study found that with a good LoRA setup, you can match full fine-tuning performance using only 67% of the compute. So it's not just easier, it's way cheaper for the same result.
But the real game changer for accessibility was LoRA. This meant you, yes, you, could fine-tune a massive 65 billion parameter model on a single 48 gigabyte GPU. That took this power out of the hands of just giant tech labs and put it directly into the hands of individual developers and small teams. All right, so it's efficient, it's accessible, it's powerful. The obvious question is this it? Is this the perfect replacement for the old way? Well, you know how it is in tech. There's always a little bit of nuance.
It's all about picking the right tool for the job. A recent study from MIT really laid it out perfectly. LoRA is absolutely fantastic for what most people want to do, which is instruction fine-tuning, teaching a model a new skill with a focused set of examples. Full fine-tuning still wears the crown for continued pre-training, which is when you're trying to inject a whole new, vast domain of knowledge into the model.
And this is exactly where Ellora comes in. With all this new power and all these new choices, developers needed a guide. Not another complicated framework, but a practical, hands-on playbook. They needed a cookbook.
You know how frameworks are. They can be awesome, but they also kind of box you in with their own APIs and their own hidden logic. Ellora's whole philosophy is different. It's about recipes, proven, repeatable methods that you can use with the tools you already know and love, like Hugging Face or PyTorch. It's all about giving you the power, not locking you in.
Okay, so let's actually flip open this cookbook. What kind of recipes are we talking about here? Let's check out a few to see what they can really do.
Ellora gives you 6 core recipes, and they're designed to build on each other. You start with the basics, like recovering accuracy. Then you move on to really practical stuff like tool use and context extension. And finally, you get to the mission-critical needs like security and even some pretty cutting-edge research. Let's really dig into recipe number 5, because it asks a question that is, honestly, critical for anyone building AI tools today. Can you actually train a model to not just write code, but to write secure code right out of the box? And the results? They are just wow. The vulnerability score dropped from over 12 all the way down to 0.4. That's a 97% drop in security bugs. But even more important is this. The model went from using secure coding patterns only 5% of the time to using them 76% of the time. It actually learned to be secure by default. Let me just put a fine point on that.
That is a 1,420% increase in the use of secure coding patterns. And the craziest part? They didn't do this by hiring a bunch of security experts to label data. Nope. They just had the model generate code, automatically checked it for bugs, and then rewarded it when it did the right thing. Okay, let's switch gears to another huge problem: reasoning. LLMs can feel like a black box, right? They give you an answer, but how did they get there? How can you teach a model to actually think out loud so you can trust its logic?
That's what recipe number 2 is all about. It uses this really smart reinforcement learning trick. Basically, it gives the model a little treat every time it shows its work before giving the final answer. The base model did this, well, 0% of the time. With the LoRA recipe, it started showing its reasoning 60% of the time, and that led to a 75% jump in the final quality of its answers. And here's the kicker: 0 human labeling required.
And these recipes aren't just about quality, they're also about scale. Take recipe 4. This thing is wild. It uses a clever learning strategy to expand a model's context window by over 60 times, from 32,000 tokens to over 2 million. Why does that matter? It's the difference between an AI that can read a single document and an AI that can analyze your entire codebase at once.
So, as incredible as all this is, you know this field doesn't sit still for a second. The technology is moving at a dizzying speed, so we've got to look at what's coming next, just over the horizon.
I mean, researchers are already working on stuff that sounds like science fiction. You have things like text to LoRA, where you can literally just tell the AI what you want it to be good at, in plain English. Or even models that can adapt and fine-tune themselves, which might one day make this whole process obsolete.
But look, while all that future stuff is super exciting, this is why Ellora matters right now. These recipes aren't just cool ideas on a whiteboard. They are production-ready, battle-tested methods you can pick up and use to build better, smarter, and safer AI today.
And that's really what this is all about. The power to customize these giant models is here, and it's more accessible than ever before. This cookbook gives you the map. So really, the only question left is, what are you going to build first?